So I am going to do some example problems, and what I have already done is I have already pre-put in a table. So anytime you are given a table, the order that you need to check them in is linear, because you can do the differences of y's and the differences of x's. The next one you need to check is quadratic, and then the next one is exponent. So I look at this and I think, oh, it's going down. Okay. So I'm going to do the linear, the linear regression. y1 tilde mx1 plus b. And I'm going to look at my r squared. The higher and closer to 1 it is, the better. And I'm looking at the r squared. Now we're at 83, so that's 83% that's an 83% best fit. Okay, I'm going to turn him off. I'm now going to do y1 ax1 squared plus bx1 plus c, and I'm going to look at my r squared, and that's a 0.98, so 98% of them fit. So between linear and quadratic, I like quadratic better than linear. And then I'm going to do exponential, y1 tilde a b x b to the x, and I need a 1. And I'm going to come down here, and my r is exactly 1. And so my equation is a linear regression. It's a perfect linear regression. And it would be y equals 1/2 to the x. Okay? So I'm going to come in here, and I'm going to change my table to -8 and -7, -4, -2, and 1. And I'm going to change this to 45 and 30, -3, -15, and -18. And I already have this set up, so my r is 0.78. My r is, let's turn all these guys off. So, if I do this one, here's my data. Okay, my r is 7.8, 78%. Here is 0.9984% and 0.85%. So my best is the quadratic. Let me look at something. -8, 45, -7, 30, -4, -3, -2, -15, 1. Oh, sorry. That should have been 18. Okay, I'm using the example 7 on your paper. Okay, so we're going to look at linear, not linear, quadratic, r squared equals 1. It is a perfect fit. It goes exactly through, it goes exactly through all the points. It is a perfect fit, 100% match. And then the exponential is not. Okay, let's try another one. I'm doing example 6, taking it from mapping. So -2 is -21. -1 is -8. 2, and then 3, and then 5. I'm taking them completely out of order because I was being lazy and didn't want to delete as much. So 2 goes to 7, 3 goes to 4, 5 goes to -14. Two goes to 7, 3 goes to 4, 5 goes to -14, -2 goes to -21, and -1 goes to -8. I look at my linear, it's 13% accurate. I go to my quadratic, it is 1. Let's put this quadratic on. Oh, there we go. Looked like a bunch of mess with just the dots, but it's a pretty narrow. So it is y equals -2x squared plus 7x plus 1. And here it is a 0.52. So when you're doing your work, it's going to give you a set of data. You're going to have to decide whether it is linear, quadratic, or an exponential by using Desmos and the regressions. You are looking at your r squared. The closer the r squared is to 1, the better fit. If r squared equals 1, then the equation is a perfect fit.